Good afternoon, class. We are going to discuss a case study on sensitization induced stress corrosion cracking on a furnace tubes. Okay, so
Sensitization. So sensitization is a process in which stainless steel is heated like up to 500 to 800 degrees Celsius, in which it has a grain boundaries where the chromium after heating into 500 to 800 degrees Celsius, the chromium is converted into chromium carbides. So in which the depletion of chromium is adjacent to the grain boundaries.
So this is
the sensitization process.
So next to sensitization process, we will see about visual inspection. Visual is nothing but seeing in our naked eyes. First part will be outer surface. Okay, in outer surface the crack will be appeared to the stop near the welded stud on both sides. Okay, and then the studs were oxidized, but no thicker scales will be observed. Okay. Seeing the picture, you can see there's a crack occur on the outer surface of the material. Okay, you can see that. So next next to outer surface, we will have about inner surface. Okay, the inner surface will have some porous or crack or a black color deposit in 5-inch width. Okay, so it also can be visible in our naked eyes. You can see that the material has some black deposit in inner wall. So that is the visual inspection in both.
So as a part of this, you have to study first fractalography. Fractalography is nothing but if you break a material. Okay, if you break a material on the breakage area, we will take a sim analysis. So that analysis, we are going to analyze what is actually happened in the broken area. So that is nothing that study is known as fractalography. Okay.
So coming to fractalography, we can easily able to see in the first image, we can see the intragranular cracking observed in the first phase, the fracture phase. We can able to see here. So and then coming to the C pic. So about that second image, the micro cracks will be easily clearly visible to our naked eyes. The fractured surface we can easily able to see.
Now we are coming to metallography. Metallography is here we are seeing a metallography which is unetched. Unetched means which we are seeing in our naked eyes without any going further process. We are seeing in our naked eyes. We have a crack there. We can have multiple cracks in the surface of the trans directions of the tube. And then next, this is another unetched metallography in which we can see that the corrosion pits with the presentation of an intergranular cracks in the tube transition direction.
So added to the point here, the metallography, in some part you can see naked eye, but mostly metallography we are going to see the particular picture by using the microscope, optical microscope, starting from 20x till 500x as well. Okay.
Now, as Char said, we can see some of the metallographies in a microscope. Here we have seen a metallography in microscope which is etched. Etched is a process where we are using some etched to make the material corrode, and then we'll take a microscope to make a test. So here we are taking the metallography. The first A image is showing that intergranular crackings, and then in the second image we are seeing the corrosion, and then in the third image, as Palak said, it's a sensitization nature in a grain boundaries.
So the metallography the carbon steel stud showed a ferrite PLA structure. The PLAtic structure regions were degraded to a significant extent as revealed by the sort of spheroidization. Spheroidization in the C, we can see the shapes which they have followed, right? So of the PLAtic region. So in this PLAtic regions, the spheroidization shapes have formed furtherly. So these are the same micrographs which we can see as the secondary electron mode as well as backscattered electron mode. Here the backscattered electron mode, it is showing the inner wall pit as well as the inner granular cracks as well. So in the previous thing, like secondary electron mode, the electron micrographs of longitudinal section has failed to tube shows an inter wall pit as well as inner granular cracks.
As we see the reason for cracking. During shutdown or cooling to room temperature in a sulfide containing environment that exists in the cooling operation, it's the sulfide often hydrogen sulfide is also known as, reacts with the moisture of oxygen, form polythionic acid which attacks the sensitized boundaries given. Okay. Under condition of stress, internal cracks from PAS.
So here the major thing is for from the case study, major study from this case study is one, as well at the lateral point of view after the operation, we can see some cracks which is due to sensitization. The sensitization has created stress in the grain boundaries. So as this stress creates the crack on the intergranulars. Okay, thank you.
Thank you.